Hello, my name is Sascha Preibisch, and today I would like to talk about FIDO2 and Passkeys. So, I did a few videos in the past, and there was never a logo of a company, but in this case, I had a talk at the Vancouver Digital Identity Meetup. We are having that in Vancouver from time to time, and it's always hosted by a company, and this time in conjunction with between Salesforce and Ping Identity. And the presentation is made on slides of one of those companies, but it's not a promotional slide deck, it's just about technology. But I thought I'll just reuse these slides in order to produce this video, because it would be too bad if the content would never be seen again, so to say. So I'm going to start a playlist with Vancouver Digital Identity Meetup content, and I hope this still works for you. So FIDO2 and Passkeys, an introduction to FIDO and Passkeys. This is not so much a completely technical detail-based presentation. It's more about the differences between FIDO Passkeys and, let's say, traditional FIDO authentication. So let's get started. On a high level, FIDO2 is passwordless authentication. So systems may authenticate users without asking for a password. FIDO2 is MFA, it's multi-factor authentication. It's always something you are or you know, so a biometric or maybe a local PIN, which is not the same as a shared password. The PIN is just a value known on your computer and not shared with an external system. And something you have, so your computer or your phone. Users authenticate using biometrics, fingerprint, Face ID, or the PIN that I just mentioned. And credentials that are created within a FIDO2 flow are bound to username, domain, and device. And we'll talk about that later in more detail. This picture down here is taken from the Fido Alliance. I thought this works really well. So FIDO is all about strong authentication, resistant to phishing, as it shows here. So it's not possible to steal a FIDO credential. And the reason for that is based on these three bullets down here. So for once, it's using public cryptography, private key, public key. The private key stays on a device, the public key is shared. And on the device until today means it's stored in a dedicated piece of hardware on your phone or your computer. And biometrics that never leave the device. As of today, if you authenticate with Touch ID or Face ID, those values that are scanned by your finger are not like a picture of your finger and then sent off to external systems. That is not happening. And because credentials are not reused on different domains and not even between different usernames and not different devices, accounts that are created using FIDO are not linkable. So this is another picture of the Fido Alliance, and I like it because it demonstrates that a registration process, which we'll see here on the left side, is almost the same as the login process afterwards. So a typical scenario would be that you visit a website and it asks you to register and create an account. And what you'll do is you'll provide a username, and then instead of adding a password, you'll choose an authentication method, which is based on capabilities of your local device. So it could be a Touch ID on a MacBook or a Windows Hello PIN on a Windows machine. And your hardware, your computer, will create a key pair, a private public key pair, just for this registration. And the private key is stored on your device and the public key is shared with the service. Sorry. And this is all that is exchanged. A username, the public key, a few more little details, but it's not really what I want to concentrate on this video. And then when you log in afterwards, it's almost the same process. So you'll have a website, you will provide your username, you hit login, and your device will allow you to choose the way to authenticate. You choose the fingerprint again if you used it before, or the PIN number if you used it before. And the device will choose the correct private key. And between this third-party service, the external service, and your device, there's a protocol where there's a challenge exchanged, which is signed by the private key on your device, sent over to the online service, and the online service looks up the public key in order to verify the signature. So no magic, but built into most of the most devices that are available today. So another piece of FIDO is the concept of attestation when credentials are registered. So if you imagine that you're using a MacBook, I'm talking about MacBooks because I'm using one myself. That's the one I'm most common with. So let's say you've got a so-called authenticator, and the authenticator is your Touch ID. When the MacBook is produced, or let's say in general a phone or a laptop is produced that supports FIDO, generally the hardware comes with a private key which is specific to the type of authenticator. And this private key then is combined with an attestation key, which is this one. Well, not combined, which is the attestation key, and a authenticator ID. And as I mentioned, this is not specific to the computer that you're holding in your hand. This identifies the type of authenticator that was produced. And this private key or attestation key is signed with a root certificate, which is held by the vendor. So they have a private key, they sign the private key that is burned into the hardware, and it only belongs to this type of authenticator. At the same time, the public key, the public part of this root certificate key pair, so to say, is published in FIDO's metadata service. And these are then called attestation certificates. So what happens is, when you get to the point where you register a credential with an online service, the public key that is sent from your device to the service is signed by this attestation key. And this online service then uses the signature to find the attestation certificate through the metadata service and verifies the signature of the public key that was given to the service. And the service can then figure out if this was a genuine, real authenticator or not. So this signing of the public key doesn't always happen with an attestation key. So the online service will receive a self-signed public key and then has to decide if this is good enough or not for the service it's providing. In most cases it is. And if you look up the Fido Alliance website, you will find many arguments why that is often sufficient. But the important message of this slide is that generally an authenticator can be tied to a vendor, and the online service can check if it is a genuine authenticator. So after registering a new credential, you'll have the following components. And I just put the slide here so that you have a simple overview of the bits and pieces that are involved with a FIDO registration. So let's say you are working on a laptop which is your device, and you've used a username for an online service, and you authenticated using FIDO. So you will now have an authenticator which remembers the username that you chose, the domain under which the online service is available, the device, which is the one you're working on, and the produced private key. And the online service remembers your username and your public key. And this is the only piece that is exchanged about you as a person. So it's, if you look at this picture, it is very, very simple, so to say. And these credentials that are created, the private key with the public key, are referred to as credential key pairs. And whenever you visit a new service or you use a different username, a new key pair is created. So now, now that we know that passwords are not needed and you can sign in and register with a biometric, there are also a few challenges with that. So, for example, if we first start by looking at this picture, just because we all know this, you will usually sign up with a username and a password for an online service. And once you've done that, you can use any phone that you own, or tablet computer or laptop computer, and use this username and password in order to sign into this online service. Unfortunately, with FIDO, this is slightly different. So, if we look at the list of comments up here, users have to register each device with the same online service. And on a Windows machine, it is the Windows machine. On a MacBook, it is the browser. So a Chrome browser is considered a different device than a Safari browser. And if you look at the picture below, this translates to, if you use a phone to create an account at this online service, you'll have to create the account for your phone, for your tablet, and for your laptop. Each single one has to be registered. And in order to register the second device after you went with the first one, as it states up here, the initial device is required to register more devices. This means that if you imagine you sign up at an online service using sasha@example.com, this username is taken. So if you now try to use your tablet, the service will say, you have to register this tablet. You'll use your username, sasha@example.com, and the service will say, well, that username is taken, sorry. So in order to allow you to register a second, third, and fourth device, the online service has to implement a protocol that allows you to reuse your username and your first initial device or a registered device, and add the device that you're working on right now. And this protocol is not standardized, so online services have to come up with their own flow. And what happens through that is that user journeys may get interrupted by sending them to the correct domain. So this is the other one, right? I went a little too fast here. So it's not only that you have to register each single device, it's also then, of course, with domains, right? And this is specifically difficult if you are on a service where you want to consume something, and another service may be the one through which you are authenticating. And I'll show you a diagram on the next picture to discuss this a little more. And then another challenge is account recovery. Since you don't have a password that you could reset, you have no way of getting into your account. Let's say if you have used your phone to create a FIDO-based account and you lose your phone, there's no one that can help you with getting back into your account because your device is gone and there's no password that could be reset. So the account recovery is something the online service has to implement themselves. And it could be with a long phrase, password, which you print out on a piece of paper and that you would then use to get into your account again. So that can be quite complicated. So the challenge with domains, let's say you have signed up with a payment service and the payment service allows you to use FIDO-based authentication. And you now want to go to an online service where you purchase items. So this online service will have a button, Pay with Payment Provider. That's the one where you registered your FIDO credentials and so you say yes, pay. And if this online service now opens an iFrame on top of itself, so to say, this iFrame will show the content of your payment provider. And the payment provider will now ask you to confirm that it's you. It will take you to the FIDO-based authentication flow and you're done. The challenge, however, is if you haven't registered with this payment provider beforehand, you cannot do that now. So FIDO credentials cannot be registered in an iFrame. And that is important to know because if this button is available and you as a user choose, okay, I'm going to use this payment provider, and this is the first time I know that, so I will also sign up during the payment process. That will fail. So this can interrupt the user journey really badly. The other case is where selecting this payment provider takes you to a full page of the payment provider via a redirect. In that case, it works fine. But if you look at current implementations, you will find online services that always stay in the background and you'll find an iFrame in front of you or in front of that page where you can walk through a payment process. And as an implementer of using FIDO credentials, FIDO-based credentials, you have to be aware of these scenarios and you have to educate your users well so that they don't get frustrated if they get stuck in an iFrame, for example. So now that we spoke about those challenges, you may have heard about Passkeys. They were announced by Apple a while ago, and they are also supported by Google and by Microsoft. And the name is derived from passwords. So instead of passwords, it's Passkeys, because it's all about keys, private public key pairs, keys. And these passkeys are not bound to single devices anymore, but they are bound to a user account. And the idea is that these user account based passkeys, they are not stored in the dedicated hardware of your device, but instead in cloud services, for example in iCloud. If you are an Apple user, you know there's iCloud, and if you have a phone and an iPad and a MacBook, and those three devices are connected with your iCloud account, you'll know that you can have certain data synchronized. So they are available on all devices. And this is the same for passkeys. So if we look at this picture, we will now find that if, for example, the phone was used to register FIDO credentials, these FIDO credentials are now synchronized with your cloud provider. And if we stick to Apple, it's iCloud, which is then distributing the FIDO-based private keys back to the tablet and your laptop computer that you may have. So the huge advantage, of course, is that you don't have to worry about the device that you're working on anymore. So it's very simple and almost transparent. Having to register on different domains or using those credentials between different domains and iFrames and redirects, that is still the same, but at least you don't have to worry about different credentials anymore. So the other promise of Passkeys is that they will work between the three major platforms: Windows, Google-based systems, and Apple-based systems. And if you follow this link down here to developersgoogle.com, you can find a few good introductions and documentation pages about Passkeys as they are supported by Google today and in the near future, and also in conjunction with Apple and Apple devices and Windows platforms. You can find out that the idea is that, let's say you've created a passkey on an Android phone, and you registered or you created an account at this online service. If you now go to your MacBook and you choose sign in with Passkeys, for example, it will work so that the MacBook will display a QR code, and the Android phone will scan this QR code. And if those two devices, your MacBook and your Android phone, are connected via BLE, Bluetooth Low Energy, then this flow via the MacBook completes using the help of your Android phone. So it mainly works so that on your Android phone you confirm the authentication process, which will allow your MacBook to sign you into this online service. The passkey itself is not exchanged, but this signing challenge that I've mentioned earlier will be received through the MacBook and signed by your Android phone. And through this process, your MacBook will either display a dialog and asking you if you want to create a local passkey or not, and use your phone in the future again to authenticate. And on your Android phone, you may get a dialog like this where you can choose the source for your authentication process. So now that passkeys help us use different devices to authenticate against an online service without having to register each single device, I would like to pull up this slide. This is how I see the advantages and disadvantages of passkeys. And if you read more about passkeys, you may make up your own mind, but this is how I see it. So one promise of FIDO was always credentials are device bound. That's not the case anymore. Unless you're using an external key like a YubiKey, your FIDO credential is not bound to the device. It's shared with your cloud service. This also means that these keys are not hardware protected anymore. So now that this device bound feature is gone, it's account based and synchronized via a cloud service, the promise is simply broken that these keys are bound to devices. And it's good for usability, and you may not really care about this because you know that services on your accounts like iCloud are very, very secure, and this may not be an issue for you. Phishing resistance is promised because these private keys couldn't leave your device. This is now different, at least for Apple. Apple supports sharing of passkeys. So if you and the recipient are in each other's contacts on your device, you can share passkeys via AirDrop. So Apple doesn't call this a chance for phishing because they say, well, You're exchanging the key with a close person, most likely. But from a design point of view, I would say if you can share it, it can be phished. But you make up your own mind, maybe. And the authenticator attestation that I mentioned earlier, where the online service is able to figure out if the authenticator is genuine, find out the authenticity of the authenticator. That is not possible anymore because those keys are not necessarily received through an authenticator directly, but through a cloud service. And therefore, the online service will not know which device was used during this authentication flow. So not a replacement, but an indicator that would provide an online service with information about the device that was used right now, and mainly letting the online service know if this passkey has been used on a device before or if it's the first time. The Fido Alliance came up with this device public key, which is created on your local device per credential key pair, and it is not synchronized through platforms. This would at least allow an online service to figure out if this device was used before in the past or not. And this is used for risk analysis by certain services. However, this protocol is not supported by Apple. So if you are implementing authentication services and the user is using a Apple device, you as a developer will not know if this device has been used in the past or not. So this was my overview of passkeys. I hope it provided some useful information. And in my summary, I would say the hope is that passwords may become less often required and you can just authenticate using your biometrics. It may help that strong authentication is used more often in more places and you do not have to create yet another account using a username and a password. And although passkeys have limitations, I'd say all other technologies have limitations too. Here are a few links to the FIDO Alliance, an explanation, an FAQ about passkeys, which is really useful and helpful, the FIDO metadata write-up, specification explaining how it works, a link to Ping, to Google, to Apple, a link about the attestation, device attestation that I've mentioned earlier, the device public keys, and the link to my own YouTube channel, which you should have if you are watching this video. Please leave a comment with questions that you may have. And I know I haven't done a video in a while, so please provide or suggest a topic that you would like me to talk about.